Hi guys, this video is going to go over how to find the domain and range of rational functions. So the first thing to note is that the domain is the set of x values that we are allowed to use on the graph. So that's going to exclude the x values of the vertical asymptote in the whole. So basically we're going to be able to say all real numbers except for the vertical asymptote in whole. Same thing for the range. We're going to have to skip over the horizontal asymptote. So the range will be all the y values except for the horizontal asymptote and the y value of the whole, which that's what we're going to kind of focus on since we haven't talked about that yet. For the questions that have to do with factoring, I am going to go through the factoring part pretty quickly. So if factoring is something that you're still uncomfortable with, you should ask questions in class and get extra help. All right, so if I'm going to do the domain, I need to be looking for vertical asymptotes and wholes. So I'm looking at my denominator, and I see that I got x minus 2 in my denominator, which means x cannot equal 2. I don't have any wholes because that doesn't cancel. So I have a vertical asymptote when x is equal to 2. So the domain of this is just all real numbers, which is that fancy R. All real numbers, x is not going to equal 2. That's it. The range looks at the horizontal asymptote. So that's when we're deciding if this is top heavy, bottom heavy, or equal. This is equal. It's the same. So 1 over 1. I have a horizontal asymptote when y is equal to 1. So my range is all real numbers. Y does not equal 1. And then this graph probably looks something like this. All right, so we're literally just skipping over the vertical asymptote and the horizontal asymptote. All right, second question, I do want to factor this denominator. That's going to be x plus 2 and x minus 2. So again, domain, I'm looking for vertical asymptotes and wholes. I know x cannot equal negative 2. I know x cannot equal positive 2. Those are both vertical asymptotes because neither of them cancel. So I have one at positive 2, and I have one at negative 2. So that's my domain. Domain is all real numbers, but x is not going to equal negative 2, and x is not going to equal positive 2. All right, horizontal asymptote, it's bottom heavy. So for my range, my horizontal asymptote is y equals 0. So that means all real numbers except y is equal to 0. And this one, I actually want to graph this one because this one has 2, the graph might do something a little bit weird on this one. So I am going to verify this one with a graph. So I'm getting my graphing calculator out. And I'm graphing the original problem. All right, so yeah, that's what I was thinking this one was going to do. So this one actually looks like this. All right, so this is a rare case where because we have 2 vertical asymptotes, my graph does actually cross in the middle. So there is actually going to be a point right here that crosses the horizontal asymptote. So in this case, my range is just going to be the set of all real numbers. Oh, I didn't mean to make that fancier. So even though there is a horizontal asymptote for this graph, when I graphed it, I saw that this middle piece actually crosses the horizontal asymptote. So that means that point exists now. So I'm not going to skip it anymore. So the horizontal asymptote, the reason why we're still including that number, The horizontal asymptote really has to do with what is happening, like your end behavior. It really has a lot more to do with the arrows to the left and the arrow to the right than it does anything in the middle. All right, so let's try the next one. I'm going to factor my denominator. That's going to be x plus 2 and x plus 5. So I know -2 and -5 for my domain. I know x cannot equal -2 and x cannot equal -5. But for my range, the x plus 2 is a whole. So not only do I have a horizontal asymptote, it's bottom heavy. So I have a horizontal asymptote at 0, but I also have a whole. So I'm going to have to find the y value of the whole. So the way that you do that is you go ahead and simplify your fraction. Cancel that out. Anytime you completely cancel out the numerator, it is 1 as the placeholder. It's still a fraction. So my simplified fraction is 1 over x plus 5. So basically what I'm doing is, and this is why we call it a removable discontinuity when it's a whole, because I'm removing the x plus 2 part when I simplify it. So this means I can plug in -2 for x. And I can do that now because now -2 is not a problem. So when I take my simplified answer and I plug -2 in for x, oh, that's positive. I'm going to get 1/3. So that is the y value of the whole. The whole is at the point -2 and 1/3. That's where the whole is on my graph. So the domain has to skip -2, but the range is going to have to skip 1/3. So the range for this one, all real numbers, y is not equal to 0 because that's where the horizontal asymptote is, and y is also not equal to 1/3. So I knew I had a vertical asymptote at -5. It's bottom heavy, so I had a horizontal asymptote at 0. So it probably looks like this. Maybe, something like that. All right, but that's how you find the y value of the whole. You simplify your fraction, you cross out the factors that made it a whole in the first place, and then after you cross those factors out, you take that x number for the whole and you plug it in. All right, so let's do the next one. I can factor out an x, and that will be x plus 3. So I know 0 and -3, x cannot equal those. All right, so I know that the domain of this function is all real numbers, but x is not going to equal 0 and x is not going to equal -3. Now, because 0, this x can cancel with this x, that one is a whole, which means the y value of the whole gets excluded from the range. So I'm going to simplify that. I'm going to cross it out. So my simplified version, do it down here, is 1 over x plus 3. So also, before I forget, it was bottom heavy. So I know that I also have a asymptote when y equals 0. So now I'm finding the y value of my whole. So the y value of the whole. So I simplified it, I crossed out the x, I have 1 as a placeholder in the denominator because I canceled, or the numerator because I canceled everything in the numerator. So now that it's simplified, I'm going to plug 0 in for x. So when I plug 0 in for x, 0 plus 3 is 3. This just happened to work out that both of these examples were 1/3, but it's obviously not always going to be that. So my range is all real numbers, but y is not equal to 0, and y is not equal to 1/3. So I have a whole at 0, 1/3. And I had a vertical asymptote at -3. And so my graph probably look like this. All right, so again, just to recap, the domain, we always exclude the vertical asymptote and the whole from the denominator. With the range, we exclude the horizontal asymptote and we exclude the y value of the whole. And again, we find the y value of the whole by simplifying the fraction and then taking the x number for the whole and plugging it back in.